Okay, in this section of the videos, we're going to look at all of our concepts dealing with decimals. So this is the models that we introduced. We're introducing a whole number times a decimal. And what you're really wanting to see are 6 different sets of 3300ths. So you would shade in one set of 33. And then your next set, using a different color or different shading style, would begin right at 34, because when we count, we don't skip from 33 to 41. We go from 33 to 34. So you would go 34, 35, and down. So for this second set, there's 7 out of the 33 that you need. So if you shade in 2 full complete columns, that makes 27. 28, 29, 30, 31, 32, 33. And then you go to your third set. Here's 4. You shade in 2 more columns. That makes 24. And that means you need 9 additional ones to make 33. So there's 3 sets of 33. We continue. We make our 4th set. There's 1. Shade in 30, 3, and pick up where we left off. So here's 8 for that 5th set. So that makes 28, 29, 30, 31, 32, 33. And leaving for that final set, 1, 2, 3, 4, 5. Then we'd shade 25, 26, 27, 28, 29, 30, 31, 32, 33. So that what we should see in total are 6 different sets, seeing that by 6 different shades. Each one containing exactly 33 of the boxes, or 3300ths. When combined all together, gives me 1 whole and 98 hundredths out of my second one, to equal a combine of 1 and 98 hundredths. And if I were to check that with the algorithm, 33 times 6, 6 times 3 is 18, carrying a 1. 6 times 3 is 18, plus 1 this time is 198. And when I add the 2 decimal places back into my number, I get the same, 1 and 98 hundredths. So let's look at that standard algorithm. So that is our next that we want to look at. So in this next 2 problems, in the first one it says that Lewis's water bottle holds 12.5 liters. If he drinks 3 bottles a day, how much total does he drink? Remember, when we are using decimals, our strategy is we want to identify how many digits are behind a decimal. So anything behind a decimal, I'm going to underline. And I'm going to see how many underlines I created. In this problem, I created 1. And I'm going to circle that, because now I'm going to get rid of all the decimals out of my problem, and I'm going to multiply this as if it were just 2 whole numbers being multiplied together. So 125 times 3. 3 times 5, of course, is 15, and I carry that 1. 3 times 2 is 6, plus 1 is 7, and 3 times 1 is 3. Now I'm going to come back to that original problem, and I'm going to see this 1 circled that tells me that I need to move this decimal from the whole number in 1 time to create the number of 37 and 5 tenths. And then the last one is 1 chocolate chunk cookie from Chick-fil-A is 330 calories, how many calories are in 1.5 cookies? I'm sorry, this is the second one out of 3. So we'll have one more in just a minute. So again, same thing, 330 times 1 5/10. I underline there's only one digit that's behind a decimal, and then I multiply it as if it were 2 whole numbers. This time I'm going to use the area model to do my multiplication. Switching up. So these two numbers are made of 330. Again, because this ends in a 0, these sets are not needed. And this number, 10 and 5, because I'm going to look at it as 15, not 1.5. So 300 times 10 and 300 times 5, and then I have 30 times 10 and 30 times 5. So I see that I need 3 zeros, and 1 times 3 is 3. In this case, I have 2 zeros, and 1 times 3 again is 3. 2 zeros, and 5 times 3 is 15, and 1 zero. 3 times 5 is 15. If I put those together on top, I get 3,300, and across the bottom, I get 1,650. And when I put those together, I end up with 4,950. However, this is not my answer because I have to go back into my original problem and see that I need one decimal place. So it's always starting at, this is a whole number. I got to put the decimal back in, so I'm starting from the back. And when I do, I create the whole number of 495 because anything in a decimal that's a 0, I can get rid of as long as it's not a placeholder. So my answer would be A, 495 calories. All right, now we're going to look at the last one. And I apologize, there are a few typos in this one, so we're going to get through it even with our typos. So Ms. Martinez will make name tags for each of her 38 students and Ms. Flood's 42 students. The materials for the name tags cost 52 cents each. What is the total cost of the materials Ms. Martinez will use to make all the name tags? So, this is a good example of names in a problem don't matter. You can always just substitute your name. So what we need to know is that we're making name tags. And we're making name tags for 2 classes. We need class 1 and class 2. And name tags for both. So, remember our think, know, and wonder chart. Okay, so in that first sentence, Ms. Martinez will make name tags for each of her 38 students and Ms. Flood's 42 students. So there's 2 things that I know from that. I need Martinez has 38 students, and Flood, or whoever you possibly made up, has 42 students. Right now, I'm not really wondering or thinking anything. I'm going to continue on. The materials for the name tags cost 52 cents each. Okay. Now I'm going to start to wonder, how many name tags in all? Okay. I know that I need 38 for one class and 42, and so I'm thinking that I'm going to need to add these to come up with a total of name tags. Now I'm going to continue. What is the total cost? Well, I know that each name tag is going to cost me 52 cents. So whatever I get, I know, I'm thinking there's going to be some multiplication in this problem too somewhere. So I'm going to start building it and building my order of operations. So I need to know I'm building name tags, and each one has a cost, and when I figure that out, I'm going to get a total. Okay, so I'm going to look. Name tags. Remember, I had class 1 and class 2. That was 2 sets of numbers. So that means there's going to have to be some math to figure out how many name tags there are. And I think there's adding because I'm combining those numbers. So 38 plus 42. And when I get that answer, I need to multiply that because each one of those is going to cost me 52 cents. And then I'll get a total. So now I can see all the steps. Step 1, I need to add, and then I'm going to need to multiply. So if I add 38 and 42, I know that 38 plus 2 is 40, and 40 plus 40 is 80. So I'm going to be multiplying 80 times 52 hundredths. Going back to my strategies up top, I need to figure out how many decimals. So if I underline, this time I have 2 digits behind a decimal. Now I'm just going to multiply 80 times 52. Okay. 80 times 2, I'm just going to look at it as a whole because even if I did partial products, that would be the same thing. 80 times 2 is 160. And 80 times 50 would need 2 zeros, and then 8 times 5 is 40 for my partial products for this one. To give me 4,160. Now I need to go back into my original problem and see that I need 2 decimal places, 1, 2, to give me a final answer of $41.60. So both of those concepts are dealing with decimals. The last thing we want to look at is area and perimeter. Area and perimeter is not new to us. The formulas, the way that we solve them are not new. What is new is that typically our shapes are going to have decimals in their numbers. So the base of a rectangular prism, so we're talking about a prism. This is a 3-dimensional shape here. So we have a rectangular prism, and one of our very best strategies is drawing out because we're talking about shapes here. And what we're talking about right now is that base, okay? So we're talking about that bottom. It says it has a length of 16 inches and a width of 4 3/10 inches. It wants to know the area. So I'm going to go back. I'm going to look at my star chart. My star chart tells me that a rectangle, the area is length times width. So if I plug these numbers in, that means I'm multiplying 16 times 4 3/10. Following my multiplication of decimal strategies, I identify that there is 1 decimal in this problem. And then I'm simply going to multiply 16 times 43. And this one I will do the partial products. That way if you did area model, you can still see what's going on. So I have 3 times 10, which is 30, and 3 times 6, which is 18. And then I have 40 times 6, which is 240, and 40 times 10, which is 400. And when I add all those numbers up, I get an 8 in the ones place. I get another 8 in the tens place. And I get a 6 in the hundreds place. But my final answer needs to add that decimal back. So I'm going to come and I'm going to add that 1 decimal place so that the ultimate answer is 68 8/10. This is area, so I have to have inches squared. So that makes the correct answer B. Okay. And the very last problem on this one is one that we oftentimes see on STAAR tests and other district tests as well as our tests. In this one, it says the side length of a square, so I'm going to draw a square, is 9 2/10 meters. Which statement about this square is true? Okay. When I get a question like this, my first strategy is I need to solve for both the area and the perimeter of this shape. The fact that it is a square means I'm going to go ahead and label that every single one of these sides are 9 2/10. Okay, so I can either add all that together, or for perimeter, for a square, I know that the formula is 4S based on my star chart. So I'm simply going to multiply 9 2/10 times 4. I'm going to have gotten rid of that decimal by understanding that I need one decimal place in my answer. So really it's 92 times 4. 4 times 2 is 8. 4 times 9 is 36. And when I put that 1 back in there, I get 36 8/10 meters because it's perimeter. Area for a square is side times side. So in this case, it would be 9 2/10 times 9 2/10. I'm going to identify the fact that I need 2 decimals because I have 2 different digits behind a decimal. And then I'm going to multiply 92 times 92. I'll do this one in a standard algorithm. 2 times 2 is 4. 2 times 9 is 18. I always have to have that 0 as a placeholder because this 9 is in the tens place. And then I may start 9 times 2 is 18. And I have to carry that 1. 9 times 9 is 81 plus 1 is 82. And when I add those up, I get a 4 in the ones place, 16 in the 10, so I carry a 1. I get a 4 in the hundreds and an 8. And then I have to go back to my original problem. I need 2 decimals. So I move it in. I end up with 84 64 meters squared. Now that I've identified these 2 things, I'm just going to compare up here. The perimeter of the square is 84 64 hundredths. I'm going to look at my work. That is a no. That does not work because that is not what I did. So I move on. The perimeter of this square is 36 8/10. That's true because 9 2/10 times 4. That's exactly what I did. So this is a maybe. I move the area of the square is 84 64 meters. That's true because 9 2/10 times 2 is 18 4/10. Well, those don't even match, and that's not what I did, so that's false, so that's out. And I just double check at the bottom. The area of the square is 36 8/10. That is not what I got. So the only possible answer was B. I hope this helps you, and I wish you all the luck on your test this week.